Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on jet propulsion of ships when inlet orifices are right angles to the motion of the ship. So exactly the theory of this jet propulsion of ships when inlet orifices are right angles to the motion of ship we have discussed in our last video lecture, and we have derived some equations. Based on that concept, we'll solve this problem. So here I have taken a question. A small ship is fitted with jets of total area. So area is given in this question. So total area is given 0.65 meter square. The velocity through the jet is 9 meter per second, and the speed of the ship is given 18 km per hour in the seawater. The efficiencies of the engine and pump are 85% and 65% respectively. If the water is taken amidship in the sense middle of the ship, determine the propelling force and the overall efficiency, assuming the pipe losses to be 10% of the kinetic energy of the jets. So this is the question given. This is exactly what we have discussed in our last lecture theory part. Based on that, the question is given here. So here we need to find out, one thing is propelling force, another one is overall efficiency. So the data are given slightly different, like efficiency of engine and efficiency of pumps are given, and some other data are given. So let's find out. So first we need to find out what are the data given in this question, then we'll go for the solution. So first one, in the first line you can see the total area of the jet is given. So we can write, so area is given, this is 0.65 meter square, and velocity through the jet is, given 9 meter per second. So here this one we need to consider relative velocity actually, not the velocity of the jet, because the velocity through the jet is given, and we cannot consider that is velocity of jet. So we need to consider that is relative velocity. This is equal to 9 meter per second. And similarly, speed of the ship is given 18 kilometer per hour. So speed of the ship is nothing but we can mark it as a u. This is given 18 kilometer per hour. So this one we can solve it like we can convert into meter per second. So kilometer we can write, this is 1000, 1 kilometer 1000 meter, and per hour is given. So hour we can write into minute, again minute into second. So finally we'll get this one, 0 cancel, 0 cancel, and this is 6 3, and this is 3 2, and this is 2 5. So the u is given 5 meter per second. Okay, and the efficiencies of the engine and pumps are given. So we can write efficiency of the engine is given, this is 85%, and this one also you can write, this is 0.85. Similarly, efficiency of the pump is given, this is given 65%. So we can write this is 0.65. Okay, if the water is taken amid ships, that means the water is this concept actually, the ship will be like this, and suppose this is the ship structure is there, and through this the water is taken. This is amid of the ship, in the middle of the ship, and here your pump will be there. Okay, and this is water inlet, this is water inlet, and the motion of this is like this. This is the motion of the ship, and how this motion of the ship happened, because of the the velocity of water which is coming out from the jet. So this velocity giving a reaction to this ship, that's why the ship is moving in this direction. Okay, now the next thing is we need to find out actually what is the propelling force and what is the overall efficiency. Now this is actually amid ship, as I told you, middle of the ship the water is coming in, and this is exactly the sea water. Okay, now assuming the pipe losses to be 10% of the kinetic energy. So pipe losses, let's consider this is HF, and that is 10% of kinetic energy, 10% of kinetic energy. So we can write this is kinetic energy equal to half mv square. So in place of half mv square, you can also write this is in place of V, we need to write this is VR actually, relative velocity. So we can write 10% of this. So 10% in the sense 10 by 100 into this is V square. So in place of V, I can write this is VR square by 2G. So here I can write this is VR square by this is 20G. This is 20G. So you can write like this. Now actually VR is given, but what about the jet of velocity? Because here you can see U is calculated, VR is given. So the V, we know that the relative velocity actually, generally the formula of relative velocity actually V minus U. But here if you see the U is moving in the reverse direction, that's why V minus of minus U, that is plus U. So we can write it like this. So we need to find out the absolute velocity, this one, jet velocity or absolute velocity you can say. So this is nothing but 9 minus 4 equal to, we can write this is 4 meter per second. Now we found here the velocity of the jet. Now we can find out the first point is given, that is propelling force. This is given propelling force. So the formula for this propelling force actually, we can write this is F equal to rho A V plus EU into V. This is the formula of this. Now here rho is nothing but density of the fluid, that is water density 1000. Area is already given in the question, 0.65 into V plus U, that is nothing but 5 plus 4 into V is how much? That is 4 meter per second. So finally we can calculate this and we can find out the value of this. So let's find out this value. How much is there? Like 1000 into 0.65 into 9 into 4, 23,400. So this is actually 23,400 Newton. Okay, this is the propelling force. Now the second one, we need to find out the efficiency, overall efficiency. Before finding this overall efficiency, we need to find out some other concept, because overall efficiency we need to consider like output of the jet and input of the jet, like that we need to find out. So we'll proceed some more steps here. So once find out the force, now I can calculate the work done by the jets. Work done by the jets, okay, per second. This is very simple. So we know the formula of this, like work done of the jet per second equal to force. What is the force we got from here into the actually work done equal to force into distance, but work done by the jet per second. So that means what is the distance per second? So you can, distance per second is nothing but velocity. So I can write this is velocity U. So we can just calculate this one. Just multiply of 4, we'll get 93,600. Now this is actually velocity here. How much U is given? 5 given. I hope 5 we have calculated. So again, what I'll do, I'll just add 22,400. So 1,17,000. This one, 1,17,000. This is Newton meter per second. This one we can write. This is work done by the jet per second. Now we'll find out. The weight of water. Which is issuing from the jet. The weight of the water which is issuing from the jet, that we'll find out. This is also per second we can write. So per second if we will write, we can write weight of the water. We know that W equal to, if I write this one, W equal to mg. So here also I can write what is the value of m. I can write the value of m is rho A VR into G. So again, let's put the value of all this. Rho equal to 1000, area equal to 0.65, VR equal to this is 9, and this is area equal to 0.65. So from here you can find out the weight of the water issuing from the jet with respect per second. So This is 1000 into 0.65 into 9 into here area is given. Okay, g is 9.81, multiply 9.81, 57,000. So here actually this is g value, g is 9.81. so final we got here 57,388.5. so this is weight per second. Okay, weight per second. Now okay, up to this we have found this is weight per second, this is work done, and this is force. Now actually the pump which is having the output, the pump which will give the output of the that will be output of the jet, okay, of a relative velocity. Okay, so output of the jet we need to find out actually from here. Okay, the pump should have the output which will give the relative velocity. Okay, so let's find out the output of the pump, output of the pump per unit weight, per unit weight. This all the things we are doing to find out only the overall efficiency actually. So output of the pump per unit weight of water, this one again we can write, this is kinetic energy of jet, the kinetic energy of jet plus the pipe losses, the pipe losses. It means, so what will be the input equal to, like what is the input was given, output equal to what we'll get, what is the input was given, by that input what are the losses happened there. Okay, so kinetic energy of the jet, which is nothing but we can say that how this fluid worked on this, and so that we can find out the output of the pump. Here what is the pump is there, what is the output of the pump, that means we can say this is the input also, we can say kinetic energy of the jet. Okay, and what is the losses happened during this flow, we can say like this. So here again we need to find out the kinetic energy of the jet. We can write this is like again half mv square, and that one we can write this is vr square by 2g, plus if you see that pipe losses already we have found there, this is vr square by 20g. Now if you add these two things, if you take a common of like vr square by 2g, then we will have 1 plus 0.1. This is 1 by like 2 gone, 1 by 10 is there, so 1 by 10 equal to 0.1, and this one we can write like vr square by 2g into 1.1. Okay, this is output of the pump per unit weight of water. Now similarly I can find out the input to the pump, what is the input to the pump per unit weight of water, per unit weight of water. This one we have found, this is output, actually output of the pump per unit weight of water. Now we will find out the input to the pump per unit weight of water. So this is nothing but we can write output of the pump, per unit weight of water divided by efficiency of the pump. So actually if you write reversely, then I can write efficiency of the pump equal to output of the pump and what is the input of the pump is given. Okay, now if you want to find out the input of the pump, then I can write in this way. Now here I can put the value of like output of the pump is nothing but already we seen 1.1 vr square and divided by this is by 2g into efficiency of the pump is nothing but 0.65 or 65% is given, that we can write. Now the next thing is we need to find out input to the pump. Actually we can write this one, we can write again one more sentence, input to the pump, this one we can write this is equal to output of the engine, So the input of the engine per unit weight of water, again, so we can write the input to the engine, the input to the engine per unit weight of water. This one we can write, this is equal to, we can write this is output of the engine, what we got here, 1.1 VR square by 2G into 0.65. We got this, multiply efficiency of the engine. Again, this one I'll tell you how I have written this one. This is efficiency of the engine. If I write, then what I can write here, output of the engine and what is the input of the engine given. Now here what I have written, input of the engine per unit weight. So input of the engine is nothing but output of the engine divided by efficiency of the engine. So this part is nothing but output of the engine, what we have got here, this one. So this is equal to input of the pump equal to output of the engine, that I have written here. So now we can find out this value. Just put this, all this value here, 1.1 into VR square. VR is 9 square divided by 2 into 9.81 into, this is 0.65 into 0.85. So this is 81 into 1.1. So this one we can write 81 into, sorry, this is 8, make it 0. This is 81 into 1.1, 89.1. So this is 89.1 and divided by, directly I'll do one thing, otherwise I'll make a divide of this 2 into 9.81 into 0.65 into 0.85, bracket close. So this is exactly 10.84. Finally you will get, with the final value 8.219. So we can write this is 8.22. This is 8.22. So you can write this is Newton meter per Newton, we can write. So this is the input. Now again we need to find out the total input of the engine. Total input of the engine. So total input of the engine is nothing but, we can write, what is the weight of water? What is the weight of water into input per unit weight? Input per unit weight of water. Unit weight of water. So here actually weight of water already have identified, and this is input per unit weight also, we know that. So weight of water already we have found in the previous one. See, this is the weight of water, what we got here, this much, okay, 57,388. So again we can write this is like 57,388.5 into input per unit weight of water, this one, input per unit weight of water. So this is 8.22. Just to multiply what we got previously, just to multiply in this 57,388.5, 4,71,705, 471,705 point some 5 we can write. So this is Newton meter. This is total input of the engine. Okay. Now finally we can write the overall efficiency. The overall efficiency we can write eta naught equal to, we can write what is the work done by the jets and what is the total input to the engine. Now work done by the jets already we have calculated in the first slide. If you see, work done by the jet already we have calculated here 1,17,000. So what I do here, just I'll divide 1,17,000 divided by this one, what we got here, 4,705.5. So just we'll do one thing, 117,000 divided by 0.471705.5. 0.248. So you got here 0.248, which is nothing but we can write 24.8%. So I can overall I can write this is 25%. So overall efficiency equal to 25%. This is our final answer. Okay. So the method is slightly lengthy, but because a lot of things are need to be identified, it is not that much simple to find out the overall efficiency from these. We need to go one by one steps. Okay. I hope you understand. Still, if you are having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you all.